All right, here we go. Good morning, good evening, good afternoon, and welcome to Neo4j series going meta. We have already achieved season 3, episode 7, unbelievably. And it was I think we announced it a couple of weeks ago, and last week I put a couple of obviously 1st of April jokes around the social media. So hopefully you didn't think I was kidding, but it's actually happening today. So I'm very excited to come back to this very interesting season an episode with our AI CTO, Jesús Barrasa, who is leading the charge in all things AI at Neo4j, but also has been the amazing co-host of this series for now a good amount of episodes under our belt. And I'm looking forward to the latest and greatest around AI technology, plus graphs, plus ontologies, and all the topics we're really covering in this series. So, hi, Jesus, how are you doing?
Hey, Alex, I'm doing great, thank you. So yeah, excited to run the new episode of Going Meta, and equally excited by the fact that at least in the northern hemisphere, spring has kind of arrived, right? So I'm loving,
Yes.
I see
Very good.
sun that I see in the back of your room. It looks like it's a sunny day over there, isn't there? Or is
It is a sunny day. Yes, yeah, it's very nice. It's since yesterday actually. It's really spring has sprung as I think the saying goes. So it's really nice. Yeah.
Yeah, and also we have moved since last episode to the what's it called, the light saving time in when days suddenly become longer. It's all it gets you in a much more positive mood. So I'm enjoying that too. But of course, looking forward to dive into all things AI and ontologies. Absolutely.
Yeah, absolutely. And because there comes a question chat from F Garau. I don't know if it's a abbreviation of some sorts. If you have to attend previous episodes to understand this one, not really. I would say you can. You obviously benefit from a couple of these are stringed together and where we build upon each other. But I think generally every episode is sort of a standalone. You should be able to follow what we discuss in all the episodes individually. We sometimes make shout outs to previous episodes, and then I link them in the video description on YouTube, and then you can check those out from before. But yeah, generally I think it's fine if you just attend this one. If this is your first episode, welcome. If you attended many episodes, obviously welcome as well. And if you are a regular, then you know this. But if you just drop in and out every now and then, that's also totally fine.
But that said, Alex, we strongly recommend to go to them.
Of course we do.
All the episodes, all the 40 something that you should, because it's amazing content that won't go out of date. So for some of them you'll find that we do kind of revisit and topics that keep evolving. But yeah, no, I think that it is a good collection of interesting episodes that we totally encourage you to go have a look. But no, we'll try to make it self-contained, and that's the plan. I mean, might make sense. We will actually today, like we often do, make references to previous episodes, but there's no expectation that you are familiar or have consumed them before understanding this. So that's all good.
No, exactly. And I'll share in chat a link to the previous episodes, so you can check that out and see what's have been covered. I've written a couple of summary blog posts once in a while. So if you look for that, you'll find them on Medium, where you see they are a little bit collected by topics and themes. So you if you look for something in specific, then look at that or look for these summary blog posts. But yeah, usually the topic is quite explanatory. We try to make it as clear as possible, so sort of what's going on when you read the title of the episode.
Good. So
and that's why we talk about agent skills, I guess. The new hot topic that everybody is discussing since
exactly.
a bit. Yeah.
I mean, it's been around for a few months already, which in kind of AI terms is an eternity. But yeah, it's relatively recent, I would say. So let me start sharing my screen. Let me know if you can see it, because as usual, we're going to start with a couple of slides to give some context, and and then we'll move into code and to some more hands-on.
Yep.
All good on that side, Alex? Good.
Yes, the screen is here. I see the slide. Yep.
Perfect. So yeah, the plan is, and to Francisco's point, I mean, it's it's kind of we're going to use this new tool, this new capability, agent skills, but we're going to apply it to something that we've discussed in the past, right? And let me go to reference these specific 2 episodes that have that I'm referring to. So the most recent one was just October last year, and that's where we had Alex Gilmore as a guest, and we went over how we could use the MCP modeling server that he had been developing as a labs project to create an ontology. Right? The ontologies are central to many of the things that we do in this series. And we saw how these MCP server that took, if you remember, 3 items. It took as input a collection of competency questions, as we call it, or some form of description of your use case in the form of questions. That's a useful way of describing what you want your model, your graph to answer, right? So that was one item. The second item was some sample data. And I believe in that case, we were using some unstructured data. And then the third item, the third input, was any previously existing models that we might want to reuse or build on top of, right? So that's what we went over, and we saw how these MCP could be used in the context of, I think we use Claude Desktop, but any kind of agent that's MCP compatible. And you went into a sort of a conversational experience where, with these inputs plus additional comments on what the agent was producing, you ended up producing an ontology that we could then use in the usual ways, right? So that's one kind of pointer to one, which is something that we're going to sort of replicate today, but with skills. And then the other one is, once we have this ontology, you might remember from January 25, that's a bit longer ago, but we saw how once we have an ontology, we can translate it in, let's call it like actionable versions of it, right? And you probably, when I say an ontology, of course, we sometimes, assume that's an ontology described in some W3C standards. That would be RDFS, that would be OWL. Sometimes we create it directly in tools like Protege. But anyway, if we start from an ontology formalizing in these standards, then we can, trivially translate it into, for example, a schema for the graphRAG package that will help us importing unstructured data into Neo. Or you can use it, you can translate it into a model that you would use in our Aura data loading experience to map data from tables or from files into Neo4j. Anyway, so once we have the ontology, we can easily translate it into whatever we want to be able to then do things with it. So that's the second part of it today, because what we're doing is exactly that. So we're going to show a new way, a new approach to this ontology creation and ontology use, but this time built on these agent skills. So before we go, any question? You probably remember, Alex, but I see you're posting the links to the previous episodes. So again, no need to go in detail over them, other than kind of understanding high level what we did, because we're going to replicate it today.
Okay. Yeah, I just put the 2 in chat and in the video description, so you'll find the links if you wanna go back into those previous episodes before.
Excellent. So yeah. Now, what are skills, right? Because that's the new toy that we're going to be using today. Oh, yeah. So just a couple of slides and a quick refresher. And you have the link there to agentskills.io, where you have all the details. But basically, agent skills is kind of an open format, as open as text, because we're going to see that it's just natural language text in Markdown that extend the capabilities of our agents, pretty much in the same way that MCP did, but slightly different. We're going to see the difference between MCP and skills. And basically, what we want to give the agent is some specialized knowledge, some skills, some instructions on how to carry out specific tasks. And one of the interesting things about skills is that they're conceived to be portable, to be easy to manage, to be easy to create, and the shape. I mean, the shape of a skill is purely a markdown file, written, called skill, like the one you see there. But it can be enriched with a few elements like code, so like things like references or assets. It can be documentation, templates. We're going to show an example of this, but the structure is very simple. It's a markdown file that describes what the skill is, what the capability that we want to describe is, and then some additional elements that complement the description. So that's pretty much what it is. Then, if we go and have a look at what's in these skills markdown file, there's two main parts. At the header, and remember, this is markdown, so it's natural language text. You will find what's called the front matter, right? The front matter is this block separated by these three dashes. And this front matter contains two elements. One is the name of the skill, and the other one is a description, right? So a simple description that indicates what the skill does and when to use it.
Yep.
Then that front matter is followed by the actual instructions. And the actual instructions is, you're absolutely free, as long as you use Markdown, you're absolutely free to describe. It can be a sequence of steps. It can be whatever description that you think is useful. So that's kind of how flexible and how easy it is to create a skill. Make sense?
Yep.
So
yeah,
so now what
is always seems so easy. And so also we did a couple of episodes recently with on Aura agents as well. It's also you type in a couple of things in the description, you give it a bit of a explanatory what you want it to do, and then it just does it most of the time.
Yeah. Well, because you will see, and basically, a lot of the things that a skill does is probably the kind of thing that you would put in a prompt, but that's exactly why they're interesting, and that's what's described there in the how point, right? So the idea is that you can have hundreds of skills, but you want to have like a catalog, and then have the agent pick the right one at the right time. So you don't want to bloat the context window, and that's exactly why we have this front matter. So the front matter, I mean, there's this idea of progressive disclosure, right? Kind of a pompous way of saying, the way they work. And then the way that works is, this front matter is loaded in the context. So the agent, I mean, the LLM, is aware of the collection of skills that exist. And that's why it's important to give them meaningful names and a proper description of what the skill does and when it's relevant, when it should be used. So that's what you have in your kind of catalog of skills. And then if there's a match, and that's how it works, first it's discovered, so we know which skills do we have. The second one, it gets activated when the task that the agent needs to carry out is fulfilled to some extent, or part of it with the content of a skill. Then what the agent will do is retrieve, and that's the progressive disclosure. The elements probably will start by reading the actual instructions, and in the instructions you might find references to the code, to the template, etc., and it will start pulling things into the context window as needed. So that's why it's new in the sense that you organize things in a way that are meant to be used more efficiently. Make sense?
Yep.
Good. So that's the idea. That's what it means, by progressive disclosure. And then what's interesting and what's the advantages is that, they're self-documenting. They're readable. I mean, as we've seen, and we're going to see in our example, it's a text. They're instructions in natural language. So something that I can perfectly go and read and understand and audit and improve eventually, right? The second one is that they're extensible. So it can be the simplest skill, and we're going to show the most, hello world example of a skill, and they can get as complicated as you like. And our ontology assistant is going to be reasonably sophisticated, but that doesn't mean it's the most complex one. And then finally, one thing that's super powerful is that they're portable. It's just a collection of files. So if you think of it, all I need to do is put and like we always do, put these skills that we've created on GitHub, and anyone can download them, install them on their environment and just have them run, because there's nothing special about it. So there's autonomous portable collection of files. So that's my brief, and of course, like everyone here, I've learned about skills recently, and I'm kind of working my way through it. And I thought that the best way to understand it is to understand them, is to apply them to a problem that we've known and approached a few times before. So that's exactly what we're going to do next. Make sense? Any additional question, Alex, before we go into the experiment?
No, sounds good. I think that's pretty clear. As always, I'd like, obviously invite you all when you're watching this live. Give us your feedback, give us questions. If you have anything, if anything is unclear, let us know. I'll be watching the chat, and we can obviously always find some time to answer questions. So
yeah. So remember, in terms of best practices, and of course, go to agentskills.io to learn more about them. But in terms of best practice, it's important to be, informative and self-contained in the front matter, because that's what will tell the LLM when and what type of problem does the skill solve or work on, and then keep that as in mind when you create it, because that's the kind of catalog that the LLM is going to have, that the agent's going to have, and what will inform when a particular skill needs to be activated and executed. So that's that. And the problem that we're going to approach, it's one that we've approached many times, which is, we have unstructured data. I don't know if it's readable, and it doesn't look as horrible. This is a medical case sheet. So it's like the notes that a doctor, in our example, they're going to be actual text. We don't need to deal with handwritten
okay, good.
text like that.
It's another level of difficult when you have handwritten text from a doctor.
Well, it would be. I'm sure there's very, very good, OCRs that can do this sort of thing. But yeah, no, we're not going to start from these. We're going to start from actual, transcripts that are properly, easily readable in text format. But ultimately, it's natural language description of a consultation from a doctor with some information about the observations, the diagnostics, etc., etc. So medical information about a patient, written as natural language, and we want to build a graph out of it. So that's the end-to-end problem, and we want to build a graph, of course, because we're going to be querying it through agents. And as we know, because we've been here many weeks and many months, we need an ontology when we want to do that, right? Because we need to guide in the construction of the knowledge graph with which are the relevant entities in my domain. Do I care about the concept of patient as opposed to football player? Do I care about the notion of condition as opposed to an artistic creation? So this kind of guidance is the one that we're going to capture in an ontology that models our domain, and that informs the entity extraction from, in this case, from the case sheets, and will produce a graph that is by design, and that's important, we'll get back to that, aligned with my ontology. And here, back to Francisco's question, you have many reasons that we've talked about on why would you want to align with an ontology, but we'll leave that to the interested reader to go in previous sessions. But let's say that in this session, we're going to focus on the creation of this ontology, and then we're going to show how easily it can be used to do this knowledge graph creation, at least the first pass on the sample data that we have. Good?
Great. Yeah.
Okay, so if that's all good, let's go try it. And I'm going to, I have here my Neo4j local desktop. We'll put that on hold for a moment, because for now, we're going to look first at the ontology creation. And what you see in front of you here is my
we still see the doc. I think
that means I need to switch. Give me 1 second.
Yeah.
So how do I replace? Okay. How do I? If I say my entire screen, that should be good, right? And like this, I can switch from one to the other.
Then you can. Yeah, exactly. I think you. Yeah. Here we go. Okay. Now we see.
So like this, I can go back to my slides, right? That's all good. My deck, my Neo4j desktop. And here, right? Perfect. So that's good.
Yep.
So I was saying that what I have here is my VS Code environment. So you might use Cursor or any other, doesn't matter. But here's where I'm going to be working. And I was going to show very briefly a couple of skills that I've created. And I've started with, obviously, a Hello World one. So first of all, skills, you put them in depending on your deployment, but typically we will go into in your project in the .agent folder /skills. So in the folder called skills, in the .agent, it might be .cloud, depending on what host you're using. But essentially, what you have in a skill, and let's go at look at the Hello World first. I'm going to make it a bit bigger. Hopefully, it's going to be more readable. Is it better?
This is perfect. Yes, thank you.
So you recognize the two elements, right? The first one is the front matter, right? So there's the that describes what the skill does. So it's hello skill, and all it does is it responds hello with a nice greeting, and the instructions, the actual instructions, well, they're my own, and I say when the user says hello, well, the agent will respond hello JB, would be me, and it asks if you've done your miles today, and add a funny joke about running, for example. That's the way I want, the knowledge I want to share and transfer to my agent on how to deal with the hello message, right? So that's how simple it can be. And then I can see it in action, opening a chat, and you'll experience my change here. But basically, the way you work here is you would select which skill to add. In my case, I'm going to add the hello skill, and just say hello. And hopefully, in this is for the testing, but if you have a collection of skills, it will be able to determine which one to use, in which case, hopefully, it will pick up eventually that there's a skill that informs how to deal with that request. And effectively, found that there's one, it calls me JB as I ask him if I've done my miles, and it gives me a joke about about running in this case. So there you go. So that's how simple it is. Basically, we've created a skill, we've made it available to our agent, and the agent has determined, given the task, which was just a hello message here, that it was relevant to use it, and it did use it. So that's the hello nice. Hello world of it. Now let's close this one and close this chat and go to our more sophisticated ontology builder assistant. Let's look at it, and you will find in it a lot of familiar things, right? So this is an ontology builder assistant. That's the name I've given it. But the way I describe it, as you can read there, is that it's a skill that will derive a minimal reusable ontology for the purpose of capturing from it's similar to the MCP server that Alex had created. So it takes some competency questions, some sample data, some eventually reusable vocabularies, some elements that can contribute to the creation of that ontology, and you will use it for things like entity extraction. You will use it for mapping-oriented semantics when the data is structured. And I wanted to use it when you're asked to create or to draft an ontology for a specific use case. So that's my attempt. I don't know if it's perfect, but the idea is that it should be descriptive on what it does and when to use it. So it might be a bit verbose, so I would let you try and experiment what works better for you. But that's my front line. And then what we have is the actual instructions, right? So I won't probably go too much into the details. Actually, we can do one thing, because it takes, well, I was going to say maybe we can run it. Let's start, showing what's in it. So the overview is what it does. It creates a reuse. Every ontology should be reusable, but it's driven. I mean, it's both purpose-led and evidence-backed, and that's important because we always insist, Alex, in the fact that we have to, that technology and ontologies in particular are a means to an end, right? So the journey doesn't end in building the ontology. We build the ontology for a reason, for a purpose, right? So, and that's what we need to capture up front, like whether it's in the form of some competency questions, like this is what I want my model, my graph to be able to answer, or this is the task that I want to accomplish. But describing the why is essential, right? So that's what I mean by purpose-led, and we're going to see how that materializes. And also evidence-backed. We're going to create an ontology that's going to work with some data to build a graph. So we need that evidence coming from the data.
Yep.
So we're saying before that I want my ontology to capture things like patients, like conditions, like symptoms. But if after that I give it the Tate Modern catalog, it's not going to be able to do much, right? Because this evidence is not supporting, the domain that we care about. So there has to be some level of overlap, obviously. So this is why what I mean by these two characteristics. And also, the wording can change, and feel free to play here. But I want to be minimalistic, right? I don't want to create a complex ontology just for the sake of it. I want to be aggressive about, hey, don't add a single thing to the ontology that does not serve a purpose. If it's not, if you cannot trace it back or map it to the competency questions, if there's not some data that I've given you as input that justifies the existing of that element, then don't put it. I mean, there's no need. So we will have a chance later on to iterate and to keep extending it if we determine that the ontology is not expressive enough or it lacks, some elements. But be always minimalistic and start small and then grow from there, right? So then comes the detail of my workflow. So this is the sequence of steps. So I say, well, first normalize the inputs, and I'm going to it depends how rich this collection of requirements or inputs are, but like in the case of the MCP server, we're going to capture some form of purpose. Why are you building these? Some sample data. And then the why, you will have kind of description of the use case, competency questions, any assumptions, anything. Some representative data. It can be structured, unstructured. In this case, like we mentioned, it's going to be unstructured data, just the records, the medical records. We're going to input some ontologies if they exist and we want them to be reused. So that's optional. And any additional semantic evidence, if I want, in this case, in general, with my skill, I try to be as generic as possible. I won't be able to provide all that in this example, but let's say that you have some sample data and some competency questions, but you have a glossary of terms in your organization. So you want to refer to documents as, text artifacts, whatever, it doesn't really matter. But if there's a terminology that you want your vocabulary, your ontology to align to, that's valid input, and we want to use that terminology. So these elements are additional input to this process. Some constraints, some formalism, some naming rules. I mean, use a particular notation for, camel case, or use all capitals, whatever it is. Here's the moment to capture all the requirements in a meaningful way, so that the more information we provide the ontology builder assistant, well, the higher the quality and the better the alignment with our expectations will be, right? So I'm saying that if there's an element missing, or one of them is thin or is very not rich enough, well, you can say it explicitly, and that's what the agent should do, and describe how can it affect the quality of the result. If it's worth stopping there, and say, hey, I cannot create the ontology if you don't give me these or that makes sense. But if not, but one thing that's important is do not invent requirements or fill the gaps. So again, we keep informing that the agent, so that it does not go down the creative path, which in this case we want to minimize. Good. So then I won't go in this level of detail on every single step, but then we build the requirements. We match them against the evidence. So we want to make sure that every element, so for every candidate, class, property, anything, they can be traced back to the requirements, to the competency questions. The same with the evidence data. So more guidance. This will be public, so you're absolutely free to use it, to comment it, to adapt it to your needs, to make it implement your own process, your own methodology to construct the ontology. Then what else did I put there? So of course, again, reiterating this idea, only if it's justified, for sure. This is one thing that I found interesting. So sometimes, in order to align with some top-level ontologies, it makes sense to have kind of a a top-level grounding scheme. What do I mean by that? So, for example, in our case, probably a key entity is going to be a patient, right? So, and maybe consultation might be another element in another concept in our domain. But it often makes sense to come up with this sort of general framework that describes, well, the world is described in terms of persons, objects, locations, and events. And your instance of patient actually is a subclass of person. And your consultation is actually an instance of an event, right, that takes place in a place. So that's sometimes useful because it reduces the cross-category confusion and enables the kind of integration with external vocabularies. Again, if you think that for your case that's irrelevant, feel free to remove, but this will be a collection of disjoint categories that kind of provide a skeleton for your domain. As always, I keep repeating, keep the small set small and useful, etc., etc. And I don't want sometimes these agents go crazy in terms of creating super deep taxonomies. I don't think that's particularly helpful, at least not in this case, where our objective is to create an ontology for entity extraction or for domain mapping. So I say, well, maximum depth is 3, and beyond 3, well, in this case, I recommend potential subclasses beyond 3, have them as annotations. Maybe I'll use them as sort of few shot example, right? So we'll see what I mean by that. I hope the example is going to produce some of those. But this is where I introduce my own. And remember that what I'm capturing in a skill is my own approach. I mean, if I give the LLM the freedom to go and create the ontology, it might implement some kind of learned approach or methodology. But I want, in my case, to follow this particular guidance anyway. So you sort of see the kind of detail that comes into this description. Now, one interesting point I mentioned before, that we may enrich our skill with things like code and additional elements, right? So and we can refer to it just with by providing the path to the element.
Okay, I see.
So what I'm saying as step 9 is before you produce the final ontology, go and run these checks. And I decided to put the checks in a separate template. And this is, again, another, it could be code, and we're going to see an example where this can be code. But in this case, it's just a list of checks that I want the element to run. So the depth test, the grounding test, the serialization test. So I can refer to these just by referring to the file. What else? I want the output of this process to follow a particular template. So I want not the ontology, which is the final product, and this is going to be serialized as RDF, but I want an output description, a rich description of the whole process, of the output of the process, and that's described in output template. So output template, you'll see it's a more formal, it's still marked down, but I want for every competency question, I want to see which is the ontology elements that have been produced to map it, why they're needed, which are the exclusions, and I can be as rich as I want here, but this is going to give me a very, very a great documentation on the whole process of construction of the ontology. And just to complete the picture here, if we go further down, I'm going to say that this is the output contract, and finally, I think I added it here. Here we go. So at the end, once the ontology has been serialized and everything, and we've put it out in the relevant directory, I say, okay, translate the ontology into actionable artifacts. And that's where I take, remember the diagram this is where I implement this wheel that it's a bit small here, but you probably remember that. So once I have the ontology, I can create anything I want out of it. And that's what, in this step, I'm going to take my ontology and create a model catalog or for the graphRAG package. Sorry, yeah, the graphRAG package here, whatever I want. And that's exactly what I'm implementing here. And for that, I wanted to use my own, my own personal code. And I actually repurposed that code in that episode. So if you're familiar with it, you'll see that it hasn't changed very much. But I can say, okay, if the sample data contains unstructured documents, it means that you're going to want to do entity extraction. And chances are, I mean, in my world, you're going to be using the graphRAG package. So if you want to use the graphRAG package, you're going to need a schema. So I'm going to do that for you. And I have the code, all to graphRAG schema code that's in this directory, in the script section, that will go and take care of that. So it will. This is the code that I refer to. So I slightly enriched to deal with things like taxonomies and things like that. But I'm providing the code as part of my skill. So the skill, like you see, is a combination of instructions, templates, even code that the LLM is going to be able to use to accomplish a particular task. So while I finish, I'm going to run it because it takes a moment for it to. So in this case, I'm going to use Claude Code just to show that it's exactly the same thing. So if I in Claude Code, the way I add context is providing this is the hello one. So oops, not now, please. Oh my gosh. I hope it doesn't ask me to restart. Did you see the pop-up, Alex?
Yeah, the pop-up was visible for a bit.
Yeah, for everyone. Yeah. Anyway, what it says is that it's by April. Oh, that's okay. So I'm for a moment I thought it was going to force me to restart.
It's doing it now. Yeah.
Just a warning. So you will need a restart by the 16th. Okay, that's plenty of time. So I just click OK and that's it. Anyway, I was saying that in Claude Code here, I pass the skill in a similar way. So this is the Ontology Builder Assistant. So I pass it there. And if I let it process it, it's going to hopefully get back to me with, hey, I understand, in this case, your skill, and I can do this and I can do that, which is, unsurprising, exactly what you like to build an ontology for. Share your case, your competency question, any sample data. So basically, it's giving me a hint on the kind of things that I would need to. And here I'm going to use something. Let me paste it, and I'm going to show the detail because, like I say, it takes a moment. So, oops, that's not the. Let me copy that here and go back to the. So this is my prompt here. So I want to create an ontology from the requirements definition in requirements definition, and I'm going to get to that in a minute. So we have this requirement scope, and also use the sample data in the data folder. So the data folder I didn't show you, but it's a collection of text files that contain, unsurprisingly, the cases that we were talking about before. So they're text already, so they can be very described. There's a patient, 34-year-old, blah, blah, blah. So this is the kind of sample data that we're going to be using.
Okay. Yeah.
Kick it off. Sorry, was that a question, Alex?
No. Let's continue.
Good. So if I kick it off, it's going to take a moment. And like this, I can show you what this requirements document looks like. So it's going to start processing. We'll get back to it. We'll let it work, but basically it's scanning the different elements. Now, what did I put in here? There you go. So let's put that on the side for a moment. And this is sort of a YAML in this case, but it's kind of a description of my requirements. And you will identify elements that we've been talking about. For example, there's the competency questions here. Right, so this is, I want to be able to answer which patients have a symptom, blah, 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 what observations, da, da, da. So, and I've given it an importance, I've given it a rationale, etc., etc. But I also have a kind of a description of the intended users, the use cases. So it's all very high level. You won't see anything here. And the reason why I put it in this format is because I'm working separately. I didn't want to bring it today because that would take longer, but the process of extracting requirements is also, it lends itself very nicely for another of these skills. And I have another skill that will help you with the elicitation of the requirements for your problem. So it can run you through a series of questions. It can take some documentation or notes or call transcripts and work it out for you. But this is something that you can use as well. And that's the great thing about skills, that they're kind of composable, right? If I provide this ontology builder assistant, but at the same time, I provide the requirements solicitation skill, I can go and talk to Claude and say, hey, I have these notes from a conversation with a customer or from a conversation with my SMEs, and I'm looking at this, and it will basically formalize your requirements in this shape here, right? So it's a way of kind of bundling it all together in something that I can then version control. So I want, think of this in the context of a process, right? I have an initial collection of my minimal set of requirements in the form, again, of use case description, scope, what's in scope, what's out of scope, competency questions, some information about stakeholders, some assumptions. Again, I'll share all these, but nothing groundbreaking here. It's just bundle it all together in some kind of YAML file that I can put on GitHub and version control as I iterate over it along the way in my process, right? I could have put it separately like we did when we experimented with the MCP server with Alex, but I thought that was a neat way of kind of capturing it and enabling. Does that make sense?
Yeah. No, it makes a lot of sense. Yeah.
So and some of these elements may or may not be relevant to your case. So these can be richer, these can be more reduced. So feel free to eliminate the ones that don't make sense. And maybe in a future episode, or maybe I could publish the skill that I've created to do that in case people are interested. But this is kind of a prerequisite in a way. So it's a way of getting help in collecting these requirements that then are going to be fed into the ontology creation assistant.
Yeah.
Got it?
Yeah, I mean, that's an interesting point as well. Where's the skill of creating an ontology? Where does that sit? Is that with a skill? Is that in the model? Is that with the prompts? Is that with a human expert? Probably it's a combination of things, but yeah.
Absolutely. Yeah. So, I mean, I would say this kind of, and this way of organizing it explains it, right? So the whole collection of these requirements, that involves, lots of players here. So maybe the description of the requirements comes from interviewing SMEs, stakeholders, who are going to be the consumers of this application that we're building.
Yeah.
So, but then formalizing it and creating an ontology that can work in the expected way, because there's also sort of implementation decisions here as well, right? So I think it's a socio-technical process that involves people and that involves. There's a third element there. So we talk very often about this idea of ontologies being not only formal, like we create them, like declarative, but it be also the result of some consensus, right? Sometimes this is created for a given project, and this is kind of the demo that we're running today. But sometimes you create an ontology to enable interoperability across departments or across functions in your organization. So how do you come up with that? Well, you have to get these two people to talk to each other. So sometimes behind the scenes, there's a the social part, the organizational part, the process part is heavier than the actual technical part. But this is sort of a bigger topic. But I hope that some light into it.
Yeah.
Good. So while we've been talking, this agent has been working, and there's lots of valuable information that's being produced, right? So here, exploring the 45, session 45 is the directory where we have it. That's our session today. It looks at the requirements. It looks at the data, like we said. It samples that. It says, well, it's thought for a moment, read sample files. Now we had enough understanding of the data variety. All this is very, very interesting, and that connects with something else, which is the kind of the reasoning memory. So the decisions that are being made along the way by following my skill. So that's interesting, because these form somehow this idea of a context graph that now everyone's talking about, and a very interesting side product of these is, what if we capture that as a knowledge, as a context graph in Neo4j?
Yeah.
Because we could have it's about to serialize and write to ontology. So I want to let him create the directory. I think that exists. For some reason, he didn't want to use my ontologies, but use the ontology. Anyway, it doesn't matter. So I was saying that, what was I saying? So I've lost my train of thought. So I was talking about. I completely lost it when I got this.
Yeah, sorry.
No. It's that's why these agents interrupt you instead of doing the job. I was probably saying that I can't remember. Anyway, I completely lost my. But it's about save the ontology, and hopefully, well, there you go. And now following the instructions, it's telling me it's about to run the command, right? Look at this. Now, after creating the ontology, it's going to convert the ontology to the graph schema, because ultimately, remember, we want to build the graph using the graphRAG package, right? So I tell it that you can go ahead and run the code.
Yeah.
So it will go ahead and execute the code, which makes sense. It asks for permission before running any code, and it will hopefully put the, there you go. So it's done now, and now it's going to give me the report according to the sort of template that I gave it and what was executed. So we're going to analyze that in a moment. Oh yeah, thanks Pablo for the reminder. So yes, the kind of reasoning memory, a trace of all the decisions that were made along the way. So storing that could be yet another input for this assistant, right? So it has the skills that describe the process to follow. It has all the inputs that it requires, but it also has memory of decisions that we're taking in the past. Some decisions might be very specific about particular projects, but sometimes this decision can be informative and can help the agent to perform better, to be more efficient, to be higher quality. So we'll explore that in another session, because that's a thing in itself. And we could even have easily maybe an MCP server that in this case keeps writing to Neo4j as decisions are being made and as the agent keeps doing stuff. But let's go over the summary. So there you go. So we have the summary. So it will give us the description of the inputs that it consumed. For each one of the competency questions, it will give us that recommended the creation of these particular classes: patient, symptom, has patient, etc., why it was needed, in which cases that could be excluded, etc. So we talked about this idea of persons, objects, location, events. So it came up with this collection of top level entities, in this case party, event, and clinical finding. So that's the collection that he came up with. We could even provide that's what I meant in at the beginning with additional context. If we have a top level ontology that we wanted to align with, well, we could have provided it and it would have reused instead of come up with its own. But this is a decent, a minimal set of top level entities that are disjoint between each other, and that then we can derive through subclass of, saying the patient is a party, the encounter is an event, and so on and so forth. So a pretty rich and well documented summary of what it's done. So what are the definitions? What's a patient? What's an encounter? What's a procedure? And so on and so forth. Make sure that all the checks that were in my template that I provided was verified. And then the final ontology has been created and put in it decided not to use my Ontologies folder, but it created its own ontology. Doesn't matter. I'm not offended by that. So that's all good. And you see that it's created. I think I also suggested in the skill to go with it's built into this idea of minimal models. So we don't want to use constructs, sophisticated constructs in OWL unless they're justified. So we have the definition of the classes, well documented. So we have the top level collection of ontologies, of categories, and then for each one of them, here's the example that I was talking about, the deeper taxonomy. So when you get to patient, right, which is a subclass of party, it's decided to, okay, maybe this is, I could have, I don't know, 20-year-old patient. It could have come up with a subdivision by age or by age range or whatever. Instead, it went with this idea, which I like, which is, okay, here are some examples of what a patient, this is a definition, right? The patient is a party who is the subject of a clinical care, blah, blah, blah. But this is an example, and this will give me few shot examples when I'm doing the extraction. So when you extract a patient, because keep in mind that this is built with a few sample files, but this is meant to work generally, right? So when we have hundreds, thousands of examples that I have not seen here, it's useful to give it the typical way in which the presence of a patient is detected. And sometimes, in this type of medical documents is by, X-year-olds, male or woman, or whatever. So this is the useful, and we use the SCOS terminology. I was doing a bit of research and on what would be the recommended approach, whether it would be an RDFS comment or a SCOS example. Feel free to use your own custom property, but the idea is making it clear that it's an example rather than a new category. So there you go. So you have the classes well documented. We have the object properties, which are the relationships, like has patient, has encounter, etc., etc. So perfect. I have my ontology, which will go straight to my GitHub repository and that my teams can iterate on. I mean, in this case, we just create the first pass, but we could go into this sort of conversational and iterative a process where we could keep refining it or keep adding new requirements or removing them until we get to the final one. But that's the kind of the central knowledge representation of my ontology. Now, what we've done as part of the process is I've translated into this JSON file, which captures the portion of the ontology that's relevant for my case, which, in the case of the graphRAG package is a description of what are the labels, which is equivalent to classes, some description, and then the properties. And the relationships should be somewhere further down. Relationship types, here we go. So that's pretty much it. So, and there's the patterns, which basically is which relationship connects which type of entity. So all this is done for free and following, well, for free. It's using, following the skills, but also using the fragments of code. So this is done in my way. So that's my personal interpretation of how, and that's one way in which skills are powerful, because you can provide your code for the LLM to do it in the way that you specify rather than be, creative or dealing with it on the fly. Perfect. So we have that. And now, just as a final test, and maybe to open it up for questions, I'm going to show how we can use this, right? And that's where I show you that we had, it's not here, it's on the other side, or maybe somewhere else, because this, where is my, here it is. So somehow my Mac likes to reorder my, so now to the left, there you go. So we have our slide, but we have an Neo4j running on desktop. So I have a running instance. If I connect to it, I've created a medical database that's empty. It's all fresh, just newly created. And if I go back to my code, I have this run knowledge graph pipeline, which is again code that you must have seen in the past because we've used. I took it from previous episodes. That's going to go and read from the data file, take the ontology. Well, not the ontology anymore. It's going to take the schema, the JSON that has been derived from the ontology, and it's going to go and apply entity extraction based on that ontology, and we will produce a graph that's going to be, by design, aligned with our ontology. The only thing that I'm going to have to change, I suppose, is because this code I wrote before used the ontologies folder.
Good point.
Use ontology, because that's what it called it. Ontology, right?
Yeah, ontology is what it's called, yeah.
OS. I think that's all. Any other ontologies? Try. Perfect. Okay, so with that, hopefully that should be, if I run Python, that's it, run KG pipeline, and I pass as input clinical case shit. Is that how it called it? No, clinical case. That's change compared to the test. Clinical case.json, right? That's the one. So hopefully that should find it. If not, it will complain and we'll figure out what happens. But it looks like it's found 15 documents, which are the ones in my data directory. And now it's going to be processing them. Right? and again, to I think it's Francisco's question at the beginning, if you want to dive deeper on what's happening here, go to episode, I can't remember which one, Alex, the one that we mentioned before from January, where you take and go and we can we'll take you through the details of how this knowledge graph building happens. But essentially, what we're doing is reading text files, applying the sort of the template of the ontology on describing which are the ontologies that are meaningful to us, and create a graph out of it that will look, as you can see, it's starting to get populated. And remember that the graph that this graphRAG package creates, it's enriched with, we've talked mostly about the domain graph, what we call the domain graph, which is the entities that I care about, the patient, the consultation, the symptom. But this is all attached to the lexical, let's call it, graph, which is a representation of the source data that provides the evidence for it. So we're going to see how we create a graph of chunks. In this case, it's a very simple document. As you saw, it's just a text fragment with, but sometimes the documents are richer, right? A document can have sections, subsections, it can have tables, it can have charts. So you will create a much representation of the lexical graph, the document graph, and then link it to the domain graph. So this is all done for you for free. And that's the graph that we're going to be creating here. So for example, let's see. So we have some fragments here. So let me see as it grows. Let's order this so that it looks a bit nicer. Document chunk, okay, entity will go down. So what do we have here? So this represents a patient. For now, what we have, well, I don't think, because this is anonymized data, so I don't think we'll have more than the fact that the age is 74 and that it's a male. And we see that the relationship has encounter. So we have an encounter on September 2007, and and we will have additional elements being added as we go. So we can check the process. Well, it's done now. So it's processed all the files. So now we have the graph, and here's probably a richer example. Let me make it a bit. I always struggle with this to take more of the state here. There you go. Well, anyway, so you probably have at the center the patient again, right? So the patient, this is a procedure. The procedure has, it's a follow-up scan. I mean, now oops, that's a bit too big. Wanted to make it readable, but that's sufficient. Follow-up scan. Anyway, so we have procedures there. Then there's a diagnosis as well. There's observation, etc., etc. So that's the graph that will be aligned, like I said, by design with the ontology that we've created. So this is an ontology, a category observation that will be described in our ontology that we saw before, that we've created, that our agent has created, our assistant has created here. So we have patient. There will be a patient definition. So probably we're gonna see it in multiple case points, but this is the class definition. So, and it should also align in the properties. For example, has patient connects an observation with the patient. So if we look at has patient, it connects procedure, an encounter, or a finding with the patient. So that's the idea of domain and range. So maybe, in this case, we went, kind of in one go to create the ontology. I would have rather maybe in this case created a reverse, a more specifically named relationship instead of a has patient as generically. Maybe the patient has finding, or maybe the patient has encounter, or has procedure. Or, well, anyway, this is the kind of more personal sometimes type of input that as a modeling expert you might want to apply in your case. Anyway, I'm going to stop here. I hope
that's something you could have prompted in the skill, right? And can say, okay, before committing to names for labels and relationships and all of that, you give me a check-in and say, okay, this is the suggested name. Are you okay with this? Yes, no, and then commit and then go through it.
Exactly. So that, by all means, that's the kind of thing where this is, and this is my sort of experimental skill, but anyone can take it and extend it and modify it.
Exactly.
And we will, bundle it, and bundle it. It's already bundled in the folder. We'll put it on GitHub as usual, and people would love to hear what people think and how it works for them and how they would modify it, or adjust it to their needs.
Yeah.
So there you go. That was the content that I had for today. I hope that was useful, and just made it
just in time. That was a lot. Thank you very much, Jesús. And then, like you said, we have obviously we will upload that into the GitHub repo, so you can play with it and improve it, or break it, or look at it, and definitely see how it goes, and see how you work with skills. I think there was one question, interestingly, I would like to look at and discuss with you briefly. Comes from Rishi. Rishi asks, is it feasible to design dynamically evolving ontologies in real-time agentic systems, and what are the architectural challenges involved? Is that something you have come across?
The question, not really, because while they can be dynamic, I don't see them. It all depends how you use them. That's the thing. I mean, in this case, you have to think of the impact that would have a change in an ontology, right?
Mm-hmm.
If our ontology is somehow the schema that we're building into our graph, a change to the ontology might mean that if it's additive, then probably not much of a problem. If it's a bigger transformation that removes elements or that renames elements, maybe that will create a conflict with pre-existing. So you have to probably understand what the impact of that change. In some cases, maybe the ontology serves a different purpose and it's not for data ingestion. So in that case, maybe it makes absolute sense. So it's more than the change of the ontology, which is absolutely possible. Is what's the impact to the processes that depend on the ontology, and what does that change mean? So
yeah, and I mean, I can imagine that this, now that you have it, I mean, your skill is very much creating this ontology, creating the schema, basically, that then is used as a baseline for dynamically or incremental loads of new data. I think that makes a lot of sense to do it like this. You can always do at some point, make a pause and say, okay, we have these kind of questions that are not covered initially in the schema, and then change the initial part, or do some manipulation from various angles here, and
Totally. Actually, I'm reading another question. Won't go too much into it, but they raised. I don't think there's a name. There's a LinkedIn user, but it raised the idea of collaboration. How do you get a team to collaborate on these? And the great point, the great thing about this approach is that we identified a couple of kind of intermediate kind of checkpoints. And one was, the ontology itself can be versioned in GitHub, so you can have multiple. Each one of us running these and pointing at the right, and ultimately. GitHub will take care of the versioning, of the collaboration, of the contributions, right? So you can build additional logic that deals with conflicts, with etc. But that's already sort of a solved problem. The other one is, that's why I introduced this idea of capturing, not formally, but in a kind of structured bundle way, the requirements. If you do that, you can also version that and collaborate as a team, right? So I would say that the whole team collaboration relies on the fact that this process produces artifacts that could be versioned themselves, because the whole point about ontologies is that they are declarative and they are explicit, and you can put them on GitHub and you can have a team sharing it and contributing to it. So I think that's a very important point.
Yeah. No, and I like that. I think that's the beauty of this is as long as seemingly complicated it looks like. I think this is a perfect example of how beautiful you can collaborate with domain experts and non-technical users together. With everybody can read a text file, everybody can come around a markdown file. I think that's relatively easy to look at it and understand what's going on, and then you can give your inputs, you can give some feedback, and then you can dynamically now even work on such a file and create it and update it, and in the end you have a very good thing that from various angles you gather input, you receive some data from various departments, and then you collaboratively work on your schema, on your baseline, and then you have a data set you can then use and work to do things with in the end.
Yeah, totally. Another comment that just popped up. These skills in session 45 is to create medical ontologies. If you were to analyze Formula 1 car performance, it would be similar, but you cannot use the skills. No, yes, you can. I mean, remember that there's two parts to it. So the skill, the ontology builder assistant, is entirely generic. So it does not assume anything. The only thing that it takes is the collection, the specification of your requirements. So in your case, you will have different. So this file created by putting it in this particular format, but you have different questions. You will have different. This is something that I can write. I mean, this is, you would say, I want to.
You're no longer sharing your screen, Jesús. So
damn it.
I don't know. Yep.
Sorry, that's where am I? Let me do, because I think that's an important. Let me comment on this one. Can you see it again?
Yep.
Okay, so I was saying that the to the left here, the skills are entirely generic. The ontology builder assistant is entirely generic. What would change is the requirements document. So the requirements document, I would say, I want to know for which team does driver work. I don't know. For example, I know nothing about Formula 1, but I think they're organizing teams as well, right? So your questions would be specific to your domain. Your requirements will be different, but the skill, this is not the skill. This is the description of what problem you want to try to solve. Your requirements. This is what would change, but the skill will be entirely generic and should work exactly in the same way. So, and sometimes
that's a good point.
These skills, they don't need to come in this format, right? So they I mean, you can write them in natural language, and I'm sure that Claude will make a good job at kind of picking them apart and understand what. So the requirements document is kind of your description of the problem that you want the assistant to help you with. So if it's not in that format, you could literally write a text document describing what's your domain. I have data that looks like this, that looks like that. I have these other questions that I want to answer. This is what's important to me. Follow this format or not follow this format is entirely irrelevant. I thought that was useful, and because that's generated by another skill that I've created. But don't feel like this is a kind of a strong requirement. Is entirely a suggestion more than anything else. And the skill, which is the important part, this. Not the hello one, but the ontology builder assistant is entirely generic. Feel free to read it, and you see that this is general guidance on the construction of the ontology. So it's not the main specific. Good stuff. Sorry, I thought I'd address that just to make sure that there was no question, but
that is important. But I mean, give it a shot, give it a go. Let us know if you build anything or if you struggle with anything. Best place for feedback on this is in YouTube at the video and in the comment section. So that is where we most likely see what you've done and let us know there. So that's where I would like to guide you to this for feedback. If you want to continue joining us in our live streams, then we are going live next week on the 13th of April, just before Nodes AI, with another Discover Aura DB episode. But obviously next week the big event is Nodes AI. So on the 15th of April we have a full day of virtual conference to talk about AI with graphs, context graphs, knowledge graphs, graph memory agents, obviously all the fun, together with graph databases and graphs in general. So join us on the 15th if you're interested in that for a full day of the event. And if you want to like to meet people in person, we have also Graph Summits coming up. The next one is in also next week in Paris. So if you're around Paris, you want to come and drop in and say hi. I think Jesús, you will be there as well. So
I'll be there. Will I meet you there, Alex?
I won't be there, but if you're around, meet and want to say hi to Jesús, then that's your chance. And if you're interested generally, know more, learn more, the Neo4j Graph Academy is great place to learn, and our developer pages give you a good place of information around all kinds of toolage, AI or not. And I'd like to recommend that to you and have a look at that for further information. As always, it's been a pleasure. Thank you very much for your watching, for your comments, for your questions. If you like this episode and this series, then obviously give it a like on YouTube. That is always helping us a lot. And give it a comment as well if you want to see more. If you have any, like I said before, questions or comments or wish list for future episodes, let us know in the YouTube comments as well. And yeah, thank you very much, Jesús. I think this was a super relevant and content-rich episode again. Lots of things for people to take away from. So if you're, really recommend you to try it yourself and dive into the skills building. I think this is a great skill to have, I guess.
Lovely.
So yeah, with that.
It was great, and yeah, looking forward to the next one. See you in a month then.
See you in May, exactly. Thank you, everybody, and